Hi there, in this lesson we're looking at trig identities and some of the uses that we have for some of these things. And a bunch of these we kind of already know because we've discussed them in kind of other aspects before. The first one are the reciprocal ratios, and we kind of already have a feel for these. The cosecant of theta is 1 over the sine of theta, and secant is 1 over cosine. Cotangent is 1 over tangent. And we can also think of these in reverse, and this is typically the way we've thought of them. You can think of sine of theta as 1 over cosecant. And then same thing with the secant, the cosine, we can think of 1 over secant, and the tangent is 1 over cotangent. So remember, these are kind of like the inverse. We know that cosecant and sine are the same thing but flipped, so they're the reciprocals of one another. And then the next couple, the quotient identities. When you think about the quotient identities, we kind of already established these when we were looking at our unit circle. Remember, our unit circle to find our tangent and our cotangent, the tangent was the sine divided by the cosine, cotangent was cosine divided by sine. Alright, so we've kind of already explored these just a little bit. And then we have a couple new ones here, these Pythagorean identities. These involve squaring some of these things. So sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. Cotangent squared plus 1 equals cosecant squared. All right. And so the first one is very similar to our Pythagorean theorem. And we can kind of prove that through special triangles in the unit circle. The next one, if you memorize these, second two are very similar. Tangent squared plus 1 equals secant. Cotangent squared plus 1 equals cosecant. All right, so there's kind of a similar relationship between those two. But what these allow us to do, these identities, they allow us to kind of take things and transform them so that we can simplify certain equations and so that we can solve certain equations that we couldn't have solved previously. Okay. For example, here's how we're kind of use these things. If I look at this first one, it just asks me to show whether the statement is true or false. And essentially what I'm going to do is I'm going to manipulate one of these sides of the equation. I might have to manipulate the other side a little bit to see if I get the same thing on each side. All right. And this is very similar to what we do in geometry when we're doing proofs, except instead of setting them up as a two-column proof and justifying each step, I'm just going to go ahead and start algebraically applying these trig identities and just see what I come up with. See if I can transform that first part of the equation into the second part of the equation. So if I scoot the second part of the equation off to the side here, I want to know when it's going to equal that. So I'm just going to start manipulating this first piece over here and see if eventually I get to just this thing. Okay? And if I get to something close or something that I know is similar, I might have to rewrite this guy as well. All right. So the first thing I'm going to do when I look at this, sine and cosine are very familiar to me, but secant and cosecant are a little bit more difficult to deal with. So typically I want to change those to something else. So the first thing I'm going to do is I'm going to change the secant to 1 over the cosine. That's one of my identities that I had. Down here, I'm going to go ahead and change this guy, the cosecant, to 1 over the sine. And now I'm just going to multiply these two fractions in the numerator and denominator. In the denominator, I get cosine of theta over the sine of theta. And now this fraction looks a little bit messy, but remember, dividing by a fraction is the same as multiplying by the reciprocal. So this is the same thing as the sine of theta over cosine of theta. So that first fraction stays the same. Times, I just multiply by the reciprocal, so I flip that bottom fraction to sine of theta over cosine of theta. And now if I look at my some of my other identities, like the quotient identity, sine over cosine is really the same thing as tangent. So what I have here is tangent of theta times the tangent of theta, which is actually tangent squared of theta. And from here, this is where it gets a little bit tricky. Tangent of squared of theta actually does equal this thing, but it might be difficult to see if I scroll back up to this identity that involves tangent squared and secant squared. Think about how I could rewrite this thing if I were to subtract this 1 from each side. So I subtract the 1 from each side, and I would find out that tangent squared of theta equals the secant squared of theta minus 1. Okay, and that's exactly what I was trying to get to here. So when I look at this, I have tangent squared of theta. Well, tangent squared of theta equals the secant squared of theta minus 1. And so now what I've shown is that first piece equaled the second piece, so I just slap a check mark on here and say, yes, this statement is true, because I was able to get from the first side of the equation and manipulate it and come up with the second side of the equation. All right, and keep in mind, we can always kind of take these identities and rearrange them a little bit. So look for certain things. You know, when you see a secant squared in your answer and you have a tangent squared that you're working with, use that identity to try to manipulate and move things around, see if you can come up with that guy. All right, so that's one of the things we might do with this. The other thing, and this is where it becomes really useful, is for something like this, if I wanted to solve for theta, really there's no way to do that right now. In order to solve for theta, what I normally do is I normally use my inverse trig function. So I do like the inverse cotangent or the sine to the -1, but that doesn't work here because I have multiple trig functions. So what I need to do is rewrite this as one single trig function. So here's what I'm going to do. I'm going to start manipulating this thing a little bit. So the first thing I notice right here is cosecant squared, and anytime I see something that's squared, I start thinking about my Pythagorean identities. And in this case, the cosecant squared is actually the same thing as cotangent squared of theta plus 1. All right, that comes right off of my trig identities. And so now what I'm going to do is I'm going to manipulate this just a little bit. If I have an entire fraction like that and I'm dividing, I just divide each piece. So if I do the first piece, if I do the cotangent squared divided by cotangent, one of those cancels out and I'm just left with a cotangent of theta plus, when I divide the next piece, when I do the 1 divided by cotangent of theta, there's really not much I can do in terms of that. That's just 1 over cotangent of theta. So I'm just using my distributive property to kind of simplify that a little bit. Forgot to rewrite this side of the equation. And now from here, when I look at combining like terms, here's a cotangent of theta minus a cotangent of theta. What's going to happen is these guys over here are going to cancel themselves out. And now 1 over cotangent of theta is the same thing as tangent of theta. So what I end up with now is tangent of theta equals 16 over 9. Well, this is one where I can simply scoot this guy over a little bit, but to undo the tangent of theta, now I'm just doing my inverse tangent. So now I'm back to something that I'm familiar with. I know how to solve this problem where I do the inverse tangent of each side. Okay, and what happens is the inverse tangent and tangent cancel each other out. So over here these guys cancel, so I just find out that theta equals, well, now this is just a job for my calculator. I punch it in, and when I do that, it gives me 60.64 degrees. And make sure your calculator is in degrees and not radians, so we get a better idea what this thing is. All right. So again, these trig identities just allow us to change and manipulate these equations algebraically. Sometimes we're trying to prove that two things are the same. Sometimes we're just using it to rewrite as one trig value so that we can solve for a particular angle. All right, and these can be a little bit tricky. Again, they're very similar to when we do proofs in geometry, so they just take a little bit of getting used to, a little bit of a feel for these things. Typically, we'll want to get rid of like secant, cosecant, and cotangent right away. All right, we want to change things to sine, cosine, and tangent, just because those are the ones we're more familiar with. Okay.